It's great to have you here this evening. Delighted that you're here in such numbers to hear Faysal Bibi from the Museum für Naturkunde of Berlin to talk about the latest news from 7 million years ago, as it were, which I love that sort of paradox. I'm not going to introduce Dr. Bibi. My friend and colleague, Dr. Mark Beach from TCA, is going to do that. I just want to say welcome, which I already have done, and say that this is the beginning of a series of lectures that we're carrying through, organizing through this semester, most of the semester, on aspects of Emirati life and culture and history. And as you can see, by starting at 7 million years ago, we're doing it in chronological order. So without further ado, I'm going to ask Mark Beach to come and say something about Dr. Bibi. Mark is the head of paleontology and archaeology at TCA, and well known to most of you, I'm sure, in the room. Thank you.
Okay, thank you, Philip. It's a pleasure to be here. I'm actually head of coastal heritage and paleontology, but it was close. Faysal Bibi is actually an assistant professor at the Natural History Museum of Berlin, as you've heard. And I actually first met Faysal in 2003 when he was in Abu Dhabi. So he's actually had contact with this part of the world and with those of us who work here for actually quite a considerable time. His research has actually covered the evolution of bovids, that means sort of antelope-type animals, and he did some very interesting field work in Ethiopia and also in Kenya. He also has been involved in the study of fossils of around 7 million years in age from the UAE, from Abu Dhabi, and that's what you're going to hear about tonight. Faysal received his PhD in geology and geophysics from Yale University in 2009. And since then, he's had a number of postdocs. He spent 2 years at the Institut de Paléoprimatologie, Paléontologie Humaine in Poitiers, in France, as an international research fellow with the National Science Foundation, and 1 year in Berlin earlier as the DAAD Leibniz Scholar. He was a Gerstner Scholar at the American Museum of Natural History in New York, so he has a New York connection prior to coming here, and he was in New York before moving to Berlin to take up his recent post. Faysal has been co-director, together with Andrew Hill of the Yale University, of the Baynunah Paleontology Project, and it's through the Baynunah Paleontology Project that we've interacted with each other. Each year for the last, you can say, 8 years, we've been spending at least a month in the field conducting fieldwork surveys in the western region to recover fossil remains from the Baynunah Formation. Part of our job, I work for the Abu Dhabi Tourism and Culture Authority. So, like I said, I'm head of the Coastal Heritage and Paleontology section. Part of our job has been to survey, map, and protect this really exciting resource. And it's great that tonight we have an opportunity to hear about some of the latest science from that. Now, Faysal was always interested in bovids, in the antelopes and things, and I said to him when he came here, no, they're not really that interesting. Elephants are really interesting, and you have to really think about elephants more, and you'll see why, I think, in his lecture tonight, why especially elephants are just one of the types of animals that we find in Gharbia Western region, and I'm sure you're going to enjoy tonight's presentation. And you're in a very special position because some of the information that Faysal will be giving tonight is really the latest research carried out by an international team of paleontologists. So partnering with us in Abu Dhabi, bringing together people from Yale, from Berlin Natural History Museum, from the Western University of Health Sciences in California. So you'll notice when he talks about some of the publications, these are recent things, these are new things, new discoveries, 2012, 2013 publications. So I hope you all enjoy the talk, and welcome Dr. Faysal Bibi.
Thank you, Philip. Thank you, Mark. And thank you, NYU, for inviting me to give this talk and hosting me for my stay here. I'm very excited to tell you about the work that I and my colleagues have been doing here in Abu Dhabi Emirate, something that a lot of people don't know about despite many years of research. And I hope with continuing discoveries, the story gets told more and more, because it's really actually a fascinating story. And the story I'm going to tell is a story of a river, basically. Freshwater, flowing year-round, supporting vegetation, which in turn supports a diverse array of animal life. This animal life includes marine predators, freshwater predators like crocodiles. It includes herds of antelopes, wild horses like zebras, elephants of different kinds. You had forests, you had grasslands. The elephants are recognizable as elephants, but they're not like elephants today. Some of them had 4 tusks, as opposed to elephants that have 2. Other elephants, such as this called a dinothere, had tusks only in its lower jaw and not in its upper jaw. Very peculiar downturned tusks. We had giraffes of different kinds, not quite the long-necked giraffe of today, something more like the okapi, which lives in the Congo rainforest. Wild pigs of different kinds. And grasslands where predator and prey roamed, just like in a savanna environment today. But this is a story of the past. And this environment that I just showed you and described to you is long gone, actually. And it existed in a place that today looks like this, which is very different. And because no scientific talk is complete without a picture of an old man in a long beard, this is Alfred Russel Wallace, who was really one of the founders of modern natural sciences. So natural sciences, we humans have always been inquisitive about our world, but we owe a lot to a few 19th century thinkers, and he was really one of the big ones who traveled the world at times when an individual could, and made observations and discoveries. He's known for many different things, but and he's named species and discovered species of all sorts of animal life living today, from the forests of South America all the way down to Southeast Asia. But Wallace's big contribution that survives in the natural sciences today is his studies on the geographic distributions of animals, and noticing that animals in certain parts of the world, which are shaded, he identified these regions, which he colored here. This is his map. They had particular characteristics that once you left that area, the characteristics would change suddenly. And so today we recognize that much of sub-Saharan Africa, for example, has its own particular assemblages of plants and animals. Southern Asia, in the tropical zone, has its own assemblages as well. And so what we can do is look at these 2 regions, for example, which is something that Wallace was thinking about, and we see similar animals. We see crocodiles in the Indian subcontinent, say, and in Africa. We see lions, we see rhinos, and many other types of animals besides. And that might lead us to wonder, well, if these closely related animals live in isolated and separate regions of the world, was there ever an intermediate geographic area that connected these 2 places? And this is exactly what Wallace had written about, discussing 2 very distant localities that are with species that are closely related, and predicting that these species should also be found, or their progenitors should at least be found, in the intermediate spaces as well. Okay? And in so doing, thinking about this concept of geography and natural distributions of animals, but also bringing in the idea of geology, which at the time was also a developing discipline, which was revealing that in fact the Earth is a very old place, compared to everything we know and everything we've seen, we're always sitting and walking on layers and layers of history. And so what does geology tell us about the world and about natural history? Well, if we just look at the planet today, this is kind of what it looks like, right? But if we zoom back 500 million years in time, okay, and I'm taking you on a big step back, it looks something more like this. Notice that the paleocartographers that made this map, and this comes from a lot of different geological sources of evidence, didn't intentionally have colored the continents as just a brown color. Notice there's no green. We're used to seeing the Earth as green. And this is because all life 500 million years ago only existed underwater in the marine realm. There weren't even any terrestrial plants at the time. So an Earth 500 million years ago would not have even had plant life on its land surfaces yet. By 400 million, the continents have moved, and we start to see the origins of land plants. 300 million, further configurations. Notice these are all alien worlds as far as we're concerned. 250 million years ago is the famous Pangea, or this time when all the Earth's continents as we know them were joined together. And then they start to separate. And as they do, we can perhaps start to recognize the boundaries of the modern world. So this was like dinosaur ages, say 170 million years ago. This is the world the dinosaurs inhabited. And around this time, we start to recognize the separation of different continents. And particularly, if you start noticing around this time, you can see the Arabian Peninsula right here. Most of it's submerged. This is where a lot of the oil comes from. It's these ancient, shallow marine layers that today are producing oils. And as Africa and Arabia take modern forms and the seaways start to take modern form, we're transitioning into the last 50 million years of evolution. And 20 million years ago, you have the remnants of a seaway that joined the Atlantic through the Mediterranean to the Indian Ocean, finally coming up to the modern configuration of today. So I've just run you through 500 million years of geology, okay, in about 5 seconds. The Earth is actually much older than that. The Earth itself goes back, 4.5 billion years, okay? And life itself is known from as old as 2 to 3 billion, starting with single-celled and then multicellular life. And to kind of put a perspective, most of the stuff that we in our daily lives think about as history, and that the cultural history we think about and the material history we think about, could really be squeezed into the last 8,000 years. I've represented 8,000 years on this 4.5 billion years by a pixel, and that's already being far too generous. It would actually be impossible to represent on this line. So this is kind of what we think of. I thought of a different way of trying to represent time, because time is a very difficult concept to grasp, really. We don't live at this scale. We live on much shorter scales. So if the Burj Khalifa at 828 meters represents 4.5 billion years of Earth history, well, then the 8,000 years that we think of as the historic period, or even more, would be equivalent to about 1.5 millimeters of the Burj Khalifa. And to express that, we'd have to zoom in to these climbers at the very top of the Burj, and then actually zoom in. I can't even zoom in anymore, but you'd have to imagine the layer of paint that covers the tip of the Burj Khalifa, and that's perhaps the proportion of time of the general historical periods that we generally interact with and think about on a daily basis. So there's been a lot of time on this Earth that we don't generally think about. And in terms of the Arabian Peninsula, we know that there are records from 150 million years back of diverse dinosaurs that roamed across Yemen or Saudi Arabia or Oman. Lebanon, actually, though a small country, preserves an impressive array of fossil life, from everything from fossil fish to remains of dinosaurs like the sauropod, pterodactyls such as this, and then also a really diverse arrangement of insects trapped in amber that's of this age, about 100, 150 million years old, and that's fascinating stuff there. The Fayoum area in Egypt, south of Cairo, is another interesting part of the world nearby. An area called Wadi al-Hitan, Valley of the Whales, and this is getting younger in time, so we're close to around 30 million years ago. And this is an area that today lies in a desert, but produces everything from the remains of ancient whales to also land animals, such as this rhinoceros-like thing called an arsenothere, as well as primates, such as this early monkey-like animal. And all the ecological reconstructions suggest that, for example, dry Egypt was 30 million years ago a heavily forested area that supported a very different style of life. Moving into the world that we start to recognize today, at around 20 or 10 to 5 million years ago, the representation in our part of the world, the Arabian Peninsula and the Middle East, is actually very little. We don't know much about this time period here. We know a lot about it in Africa and Southern Asia, but really the most important site to tell us about this time period between 5 and 10 million years ago, when we start to see the emergence of modern animals and modern geographic associations, is right here in Abu Dhabi Emirate, in the Gharbia region. There are a set of rocks that have been termed the Baynunah Formation. Okay, Baynunah is also the name of a region, part of Gharbia, hence the name. These sets of rocks are about 7 million years old, and in them we find a diverse range of fossil animals that give us clues about what the environment was like in this part of the world a long time ago. Al-Gharbia lies in western Abu Dhabi Emirate. The actual region producing fossils is very large. It's more than 200 kilometers long and about 50 to 60 kilometers deep from the coastline in south. Here is the latest map combining our knowledge of the fossil areas, starting all the way from sites like Rumaitha, heading out to Jabal Danna, Ruwais area, island called Shwayhad here, Jabal Baraka, and all the way fairly deep inland, okay? And these are all the areas where the Baynunah Formation outcrops and where we have collected fossils of different kinds. And this is what the landscape looks like today. And this is what the fossil evidence tells us it looked like in the past, okay? And so how do we know this? Well, first of all, it's just standing on this landscape here, and this is on the island of Shwayhat. Right now, where I took this picture, I'm standing on 60 meters of layers of sands and clays that are called the Baynunah Formation, and immediately to a trained geologist's eye, these sands and clays can be inferred to have been deposited by a river. Okay, so they're not marine, they don't come from seawater, they're not wind-driven accumulations such as desert dunes. They're water, freshwater sands that have been deposited. So immediately this is a clue to the existence of an ancient, long-lasting, and large river system that deposited over 60 meters of sediments. And this is what it looks like when you're out there. So here's the paleontologist walking along the outcrop, searching for the right moment when a fossil buried for millions of years has been exposed to the surface by erosional processes, mainly wind here and what little rain there is, and starts to tumble out of the ground, and we hope to catch it before it's tumbled too far out of the ground. The landscape further inland looks a bit like this, and this actually, you can sometimes see conspicuous mounds, and when you get closer you realize they're bones, and this is what elephants weathering out look like in the desert. They're large animals, right, and their bones are very dense, and as the ground erodes away around them, the dense accumulation of bones here actually starts to make its own little hill that's more resistant than the surrounding sediment. This is a crocodile skull coming out of the ground as well. We had just started to excavate the snout area here, going to the back of the head. I'll show you a better picture of that in a bit. And out here on this barren-looking landscape, staring out onto the landscape is a chunk of elephant tusk. Okay, so 7 million year old ivory, if you like, sitting here weathering away one piece at a time. So this probably came to the surface, who knows, maybe 1,000 years ago or 500 years ago, and has been being chipped away by wind and erosional processes, because that's the natural way things work. This area has been known to produce fossils for quite a while, starting with oil surveys in the 40s, 50s, and 60s, and then continuing with a major expeditionary work, especially in the 80s and 90s, led by Peter Wybrow of the Natural History Museum in London, as well as my colleague Andrew Hill at Yale University and Walid Yassin of the Al-Ain Museum. And this work resulted in publication of an academic book, if any of you are interested, back in 1999, describing for the first time in detail the kind of animals that lived here. Since 1999, myself, Mark, and Andrew Hill have combined forces and started a second expedition to recover, find more sites, and find more animals, and increase the diversity and our knowledge of these animals that used to live in the region today. Our work takes many forms. Sometimes we're excavating, sometimes we're sieving for very small fragments of animals. Generally, we walk around, we do long surveys, and we find fossils as they wear to the surface. And as we do, we excavate, sometimes using specialized techniques, gypsum plaster, whatever each individual fossil requires. And this is what the fossils look like. So if you walk into a museum and you see articulated skeletons, beautiful articulated skeletons of fossil animals and things like this, well, that's actually very rare. Most animals die, they get incorporated by moving rivers, and their animals moved around. They've probably been eaten, maybe trampled in the process beforehand. By the time their bones enter the fossil record, they've been mostly destroyed, trampled, and isolated. And that's the situation we find them in as they weather back to the surface years later. But with knowledge of anatomy and comparative anatomy of animals, one can find the diagnostic parts of the skeleton and know exactly what animals these different parts come from. And so in this illustration here, we have this fossil giraffe, scientific name Paleotragus germanii, which is mostly also known from East and Northern Africa as well. We had an excavation where we covered many parts of this animal, including its long forelimbs, parts of its feet, ankle bones, parts of its neck vertebrae. So that's one of its neck vertebrae, indicating that it had an elongated neck, kind of like a camel, as well as parts of its skull and its lower jaw. We have many, many different kinds of fossil antelopes that come from this region, including this beautiful skull here with the nice horns, an animal that looked like this, which we call Tragoportex. We have numerous bones that indicate the diversity of sizes of antelopes, everything from the large here to, this is my hand holding a jaw, a complete jaw of a very tiny gazelle, okay, ancient gazelle that lived in the period. And this is part of the skull and the right horn of another small gazelle. We had extinct fossil equids, or members of the horse and zebra family, okay, that roamed around these plains. They're represented also by diverse elements from the skull all the way through the limbs. And for example, this bone here, you wouldn't find in a modern horse. No modern horse or zebra has this bone. Why? Because these horses, instead of having one hoof, okay, one toe, had three. Okay, so they're a much ancient, more primitive form of the horse that used to roam around far before the modern horses we know evolved. Fossil pigs and hippopotamuses, also extinct species. There was a small hippopotamus here, probably only a little bit larger than the dwarf hippopotamus that occupies West Africa today. They were very plentiful in the Baynunah River, as well as no less than 2 species of wild pigs and wild hogs that roam the region. We had the carnivores, of course, because where you have prey, you have predators. Everything from some large chomping hyenas, which we know from their teeth and limb bones, as well as some saber-toothed cats, okay, large, fast, powerful moving predators. And then this is one of my favorites because you've probably had to take my word for it on all the last fossils that I've shown you, that this is a tooth and this is a limb bone and this is but I don't know if any of you can see for yourselves what this could be here. It was a really nice fossil to find because it's in great shape and it's actually very iconic. But that is a crocodile skull. And if I say gazelle in Abu Dhabi, I mean, I might know this is an extinct form, but gazelles do live in Abu Dhabi today. But this is a crocodile, okay? Out in Gharbia, okay? And it's a beautiful skull. And so things like these get collected in gypsum jackets, and then they await further preparation, conservation work, study, publication. But the fossil crocodiles are one of the most plentiful, actually, animals we find out there because it being a river, there are also some of the most plentiful animals living and dying in the river to be preserved. So we have plenty of crocodile teeth. These are called scutes. They're actually, crocodiles have bones in their back, in their skin. These are serious predators, right? They have armor, and we find parts of their armor here. And we even find their droppings, okay? So this is crocodile poo-poo that also gets fossilized, okay? We have fossil birds. This is a very diverse fauna. We have fossil birds that resemble living egrets and cormorants, which today can still be found in the Gulf area. And we have a fossil ostrich that's much larger than any living ostrich living today, okay? And we have a very spectacular, actually, hip bone, a very fragile bone, which we were very lucky to find and which we've since collected and are now preparing for publication. We also find eggshells of these animals today, which look very different than the living ostrich eggshell. The diversity goes on. We have fossil shells, such as these bivalves, and these are another indication of the river because these are freshwater clamshells, okay? They're not marine clamshells. We have little snails that used to live in the floodplains, the ancient floodplains, and large chunks of trees and fossil woods that indicate the ancient woodland habitats in the area. We even find evidence for insects, okay? So we have ancient termite nests, okay, exposed in these exposures, and they're a little hard to see, but these lines you see here are the filled-in remains of the ancient termite burrows, and these large saucer-shaped features are what are called the galleries of the termites. They're like the rooms inside these intricate chambers, and so termites today in Africa have massive underground chambers and also produce these overground chimneys, as they're called. We even have dung beetles, all right? So here's a big chunk of a fossilized dung beetle mat, and you zoom in and you see these balls here, and these are fossilized dung beetle balls, okay, which again today exist in Africa. These are beetles that will collect especially elephant dung, roll it up, and then that's their living environment. Moving into the smaller world, we have fossil monkeys, which are extremely rare and very hard to find. And this specimen I'm holding here, we found a few years ago, is a single tooth of a guenon-like monkey. And guenons are only known from Africa also, and yet here we found one in Abu Dhabi. This is a CT scan of that tooth here. And this is a new species, actually, that we're going to name, that will be named for the area, and that will be announced very soon. But if you thought that was small, this is really small. That's a 1 dirham coin, and fitting very comfortably on this 1 dirham coin are 5 fossil specimens, okay? And these are rodent teeth. These are fossil rodent teeth. The massive one here, that's an incisor, okay? So the chisel-like front teeth of rodents, okay? That's one of them. And then you have 4 specimens here. Each one belongs to a completely different species of a fossil rodent. And so, as you might imagine, finding something this small requires special methods that need to be applied. It's not the same as finding elephants that give themselves away as conspicuous mounds on the landscape. So sitting here on this picking pan is a fossil tooth. And if you'd like, you can try and take a guess. This is what we have to deal with. We do this for hours and hours and days at a time. But the fossil tooth is that one. And that's a big one. What this involves is selecting very small parts of the Baynunah exposures, okay, based on our understanding of very local conditions and a certain amount of trial and error, and going through hundreds of kilograms of the sediment, running it through 3 different sizes of sieves, okay, to take out the sand, and then we take out the pebbles, and we take out as much as we can. But as much as you take out, you're still left with pebbles that are all the size of rodent teeth. And the job is to sit there hours at a time in a team with these aluminum pans and pick through 1 grain at a time until you find 1 tooth at a time. And on a lucky day, you know, in a 10-hour workday and several hundred kilograms of sediment, we'll find 10 teeth. And that's a great day. And some days we'll find 2. And then once these teeth get collected, they could be studied in our controlled space, obviously using microscope equipment, but especially scanning electron microscopes. So that is an example, a single tooth. That's right when I found it, I put it on my finger and photographed it in the field. This belongs to an animal that's kind of like a living gerbil, okay? And it's one that's named for the area because it was first discovered here. It's a genus called Abu Dhabi, species Baynunensis. And this is that tooth blown up on a scanning electron microscope. That's 100 micrometers, so that's 1/10 of a millimeter is this little bar here, okay? And this is the big tooth I showed you earlier on the picking pan, all right? And so that one's much bigger than the last one I showed you, but still, that's my fingernail, so that's still for size, but that's a massive rodent, okay? So this is an ancestor, if you like, of the living cane rat, which again occurs in Africa today. And these are also called swamp rats, and they're these massive, massive rats that also like wet habitats, and especially agricultural areas that are well watered. And that's a scanning electron microscope image of that. And we actually published a new species, the swamp rats that we found here in our work turned out to be a new undescribed species, and in fact, if you like, a kind of missing link between previously known species in Africa and Asia and the living species today in Africa. And we named it, we had fun with this because the teeth were always reminding us, you get hungry working in the field. And the teeth, these little yellow teeth were always reminding us of hummus, yeah, of chickpeas. And so we thought, and it was also the time when there was kind of cultural hummus wars going on in the news about who invented hummus and who can make the biggest vat of hummus. So at the time we decided we're going to name this thing Proto-Hummus Dango, okay, in honor of Dango, the Emirati hummus dish. And it works perfectly because most scientific names for rodents ends in mus, which means mouse. Jumping to the other end of the scale here, and these are the elephants Mark was referring to, okay? So here in the ground, far too late to be collected, but beautiful in the ground as it is, are the remains of an elephant tusk, the last skin of the ancient ivory that would have been in the ground here. And here are already jacketed in gypsum with our conservator from the LP Body Museum are the lower jaws of an elephant, okay? Big animals, heavy fossils needing a lot of work. These are pictures from an excavation of a whole elephant skeleton on the island of Shwayhat that the Natural History Museum London team conducted in the early 90s. It took them actually several months and many visits and a large team in order to recover many different parts of the skeleton. And thanks to the abundant elephant remains we have, we know that we had at least 3 species, okay, roaming around ancient Abu Dhabi. Think about that. Living elephants, we have the Indian elephant and we have the African elephant. The African elephant arguably is 2 species, but they look actually quite similar. In effect, we have 2 species of elephant living today on the world. Imagine that in Abu Dhabi in the past, in Abu Dhabi alone, you had 3 different species walking around, okay? And they all had peculiarities and major differences from living elephants. This is Stegotetrabelodon, which at the time is closely, actually the closest thing to the living elephants today. It's on that lineage, if you like. These dinotheres were peculiar things, almost like evolutionary holdovers from a much longer time period before, and they died out in the last couple of million years, but they were here in Abu Dhabi. And then we also had these what are called shovel-tusked elephants, such as this ammobilodon here, where they had peculiar lower jaws shaped as shovels, which we think they used to maybe root up different kinds of plants that they would eat from the soil. So I hope I've given you an idea of what these animals look like from the bones that we find, okay? So we find these bones and we know these animals were here, and we can draw this picture, which this may look deceivingly like a modern African savanna, but none of these species are alive today, except perhaps the crocodile, which may be the same species as the Nile crocodile. Everything else are extinct species, okay? And this is what Abu Dhabi would have looked like at that time. But what if we want to ask about a different dimension of animal life? And so look at this picture here. I've been talking about elephants. These are elephants. But there's so much more, too. This is a herd of elephants. We know that elephants are very intelligent animals. They're sociable animals. They have very complex social structures. So, for example, elephant herds are led by females. There's a matriarch, okay? And the males lead solitary lives instead. And so elephant herds are also called families because they're all closely related individuals that live together, cooperate, and have seasonal and yearly routines that they follow in order to survive and follow their resources, okay? Highly organized life. The groups led by females here, whether they're Indian or African elephants, they have the same complex social behaviors. And the males, once they hit puberty and sexual maturity, they go off and they lead solitary lives. Sometimes they may band with other males, but for the most part, they live alone their whole lives, okay, 50 years plus. And they come back and reunite with family units in order to reproduce. Now, what if we were looking for information about social behavior in the fossil record? Where might we look for that? So the bones are great to give us indications about the anatomy of these things and their evolution and what species it is, but they're relatively static in terms of social behavior, okay? Or anything that we might like to color our picture of the Baynunah fauna with. Well, this picture here of elephants walking in Namibia gives you a clue of what elephants may leave behind for us to find millions of years later that might give us a sense of their social behavior. And for this, we're going to leave the coastal sites rich in bones, and we're going to move inland about 30 kilometers to these areas which are conspicuously white on Google Earth imagery. They really crop up. And that's there because there are these massive exposures of carbonate, which is like a limestone, calcium-rich mud that has hardened and is exposed very widely and is highly reflective on the satellite imagery. These areas are not very conducive to finding fossil bones, but they are conducive to finding fossil footprints. And so what you have on the left is a site called Mlesa 2. And at this site here, if you can see the left, right, left, right, left, right, left, right, left, right, left, right, going off into the distance, is the footprint trail, the fossilized footprint trail of an animal that was either a horse or an antelope. Okay, we don't have enough detail of the feet to say what it was, but we can say from the size of the animal that it was in that size range. Even clearer, however, are sites where we have left, right, left, right, left, right, massive circular depressions, deep, that could only be elephants. And so this site here, Mlesa 1, preserves trackways of elephants, okay? And this is one here, but it's not just one elephant. Actually, looking down the trail here, you can see here's a track. The track I showed you was over here, okay? And here's another one, and there's 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 another one. And we'd known about this site for years, and actually local people knew about this site for years, and it was local people that actually first showed my colleague Mark this site to say, look, there are some fossil footprints here, you should come check this out. And standing on the site, it's very hard to make sense of what you've got. It's huge, it's massive, okay? And this gives you a sense of the best one could do standing on the site, trying to figure out what these are, what these prints are, where they mean, where they're going. How do they connect to each other? Are these many different individuals? Are they walking together? Are they walking apart? And so for years we'd come by, look at this site, scratch our heads, think about how nice the site was, but then not know what to make of it. Until one year I met this guy. He's an archaeologist who works in Peru, nothing to do with the region, but he's a specialist in grabbing a Nikon camera, attaching it to a kite, flying the kite up in the air, and taking photos of the ground, okay? So the problem with our site was it was too big to study from the ground, and it was too small to use satellite imagery for, okay? There was nothing resolved enough to get us in that right scale. And so my colleague Nathan here, we brought him in. I said, yeah, I'd like you to try and take some photos of this. So he runs his kite across the site, snapping photos the whole time, and then later constructs a digital photo mosaic. And this is what it looks like. This is a constructed photo mosaic of over 100 images of the site, okay? It's a little hard to see, but the scale here is huge, okay? So that's 250 meters, this bar here, okay? And the first trail I showed you is this one, and that's a 260 meter long elephant trackway moving on its own, okay? Perpendicular to the many trackways that all seem to be moving in the same direction and moving side by side. And from the moment we were in the field and the first night, Nathan starts bringing up some of his photos on the laptop that he'd taken that day, and we realized that for the first time we could see, we could see the forest for the trees, as the proverbial expression goes. We finally were looking at events. We were looking at ancient fossilized events. And here in this artist's reconstruction, the photo I showed you earlier, but what we had here was a herd of elephants walking in one direction, and then a single solitary elephant walking in a totally different direction here. And really the beauty and the detail of this photo mosaic, and it's up online actually, you can explore it at full resolution for yourselves, is phenomenal. That's a baby elephant right there, okay? And the individuals here, we could finally for once start to trace them all the way right through. This is the single biggest individual in the herd, okay? That was probably the leader of the herd. And with all the other individuals walking side by side and slightly behind each other. As soon as we saw this in the field, we got to work. We started printing out some of the imagery, making notes, taking measurements in the field. And what we were interested in are stride lengths. So for each trackway, we started to trace on the imagery, okay, the different trackways, so we could finally line them up because this was impossible to do when we were on the ground. And a stride length is basically the distance from when an elephant puts one foot down, okay, and then the distance between when it put it down the first time to the distance it put it down the second time, okay? So stride length for human would be, that. It's about a meter, okay? And your stride length, as you can imagine, is related to your height, okay? So taller individuals will have longer strides. And what we were getting at here was basically we were interested in the distribution of sizes of these elephants that were all moving across the landscape. And we had all this stride length information. And in the process of studying this imagery, we actually compiled a beautiful map tracing all the way through, and we compiled stride length information in the field and then digitally from the photo mosaic for the entire area, okay, doing a study at multiple transects in the area here. And so we suddenly had all this stride length information about the herd structure. But I wanted to translate that into I want to know how big are these animals, okay? How big are these elephants that used to walk in the area today? And so I turned to a colleague of mine, John Hutchinson, at the Royal Veterinary College in London. And his job, oddly enough, is to study elephants running. So this is the one guy in the world that has a ton of data on how elephants move. They take elephants of known weight and they watch them move. They attach, they put landmarks, they paint landmarks on them so they can see them move, and then they make them run, okay? And they have them running and walking and slowly walking, and so they know their speed, they know their size, and they know their stride lengths. And so thanks to John's data, we were able to calculate, very simply do a backwards calculation using the stride length data we had, and determined that the single solitary trackway was actually the biggest individual and weighed anywhere between 5 and 6 metric tons, okay, between 5 and 6,000 kilograms. So that's in the range of an African elephant today, a male African elephant. And that the herd was comprised of a whole range of sizes, including what's a young elephant at, only about 1,600 to 1,000 kilograms, okay? Stretching all the way up to the biggest individuals, which approach the male elephant in size, okay? And so here it is, preserved in the footprint record. We have basically 7 million years ago the early history of modern-like elephant social behavior in all its complexity, in its sexual diversity as well, in the larger males living solitary lives, and the herds comprising probably related individuals of different ages moving together across a landscape. We published this work last year in a journal of the Royal Society called Biology Letters, and this is what Mark's talking about. So rodents and antelopes and all this stuff don't get much media attention. People love elephants. This is what we learned. We had TV, radio, we had worldwide media coverage of this, and it deserves it. It's really a beautiful site. It's unique in the world. You can find trackway sites all over the world and from many different ages. You can find them in North America, you can find them all over Asia, Africa. But here in Abu Dhabi, this is the single trackway site of this age that records a social group moving across the landscape, okay, in this detail and at this size, which permitted this kind of study to be done. We had an artist come in and do a paleo reconstruction, okay, of the herd. So this is what it would have looked like. These animals moving across an ancient, muddy, flooded algal mat landscape, okay, large expanse of probably seasonally flooded flatlands. Rich in calcium, that's why as soon as these elephants walk through and these things dried up in the sun, they bake. They bake like clay, like brick, okay? So what I've given you, I hope, is a sense of how the modern landscape of Abu Dhabi was at a certain point in the past, very different place, much greener, and full of a diverse array of vegetation and animals that subsisted along the banks of a river. And so what does this inform us in terms of a big picture and in terms of Wallace's predictions about finding intermediate geographic zones in between isolated geographic zones today? So what has geology told us? Well, in terms of this conundrum, of this separation today between African and Southern Asian tropical faunas, the Baynunah assemblage fits right in the middle of this picture, okay, and tells us about a time when these tropical animals roamed across large expanses of Africa, North Africa, even into parts of Southern Europe, okay, through the Middle East and into Southern Asia. A beautiful, continuous region. And I'd just like to end with a small story that relates some sense of the depth of time and the changes that accompany time. And it's interesting to seek where in history this kind of conception of deep time may have come from. And very interestingly, narrated in Charles Lyell's book Principles of Geology, 1830, is a story by an Arabian writer, apparently by the name of Muhammad Qazwini, okay, who lived at the close of the 13th century, okay, of the Common Era. Okay, so we're in 1200 something. And here are writings preserved in Paris at the Royal Library, which tell a story that says, story of a traveler, that says that I passed one day by an ancient and wonderfully populous city and asked its inhabitants how long it had been founded. And the inhabitants, of course, replied, it's a mighty city And we know not how long it has existed, and our ancestors were on the subject as ignorant as ourselves. 5 centuries afterwards, this traveler returns, okay? And he passes by the same place, and he cannot perceive the slightest vestige of the city. It's gone. He demanded of a peasant who was gathering herbs on its former site, how long had the city been destroyed? The peasant replies, "What a strange question. The ground here has never been different from what you see before you." "Was there not of old," I said, "a splendid city here?" "Never," he answered, "so far as we have seen, and never did our fathers speak to us of any such city." 500 years on, he returns to the same area and finds that the seas have in fact come and taken over what was previously dry land. He inquires of the fishermen fishing there, "How long has the land been covered by waters?" And they respond, "Is this a question for a man like you? The spot has always been the sea. It's always been what we know it to be now." Lastly, on coming back again, after also another 500 years, he found there a city, once again, flourishing, more populous, and more rich in beautiful buildings than the city he had seen the first time. And when I tried to inform myself concerning its origin, the inhabitants answered me, can you guess? "Its rise is lost in remote antiquity. We're ignorant how long it's existed, and our fathers were on the subjects as ignorant as ourselves," okay? Here, beautifully, in the 13th century Arabian literature is the conception of remote antiquity, of deep change of time, of landscape change, okay? And the Baynunah River is gone. The animals and plants that lived on its banks are gone. They've moved on or gone extinct. And sitting today, this piece of elephant tusk, looks out on a 21st century landscape, a 7-million-year-old tusk looking out on a 21st century landscape. And this tusk lives in remote antiquity, okay? But we ourselves no longer need to be ignorant about this remote antiquity. And in fact, even here in Abu Dhabi, we have the clues of it right before us. All we have to do is look, and we can find them. So, with that, I'd like to say thank you to all my colleagues and to NYU.
Are you saying that climate change was the biggest factor in the change in the topography?
Absolutely. Animals track environments. To a certain extent, animals evolve in response to environments, but there are limits. There are limits to the rate that the response can go at, okay, that ecosystems can respond to environmental change. But there are also limits to, for example, you can't keep a tropical ecosystem alive without water. And so if at some point, for example, if the monsoonal patterns that we know today used to come all through the Arabian Peninsula and supported these kinds of river systems, and those drifted away, those would take away the water, and that's it. You'd lose the diversity of life that lived here. So inevitably, there is a climatic factor here. And you can even see it in the rock record, actually. The river sediments become less and less indicative of a strong and big river system, and you start to see what could be more seasonal kind of flooding events, which suggest a much less permanent source of water already, even in the top of the Baynunah Formation. Yeah.
How does these drastic climate changes before the human era, how does that inform or relate to the idea that humans are behind climate change and kind of human civilization? And
Well, whoever's behind climate change to start, what this immediately informs us, and the question I just answered is that when climates change, everything else changes too, okay? And climates have always changed in the past. They've gone from warm to cold, continents have come and gone and separated, and seas have come and gone, and this is natural. This kind of stuff happens. What what we also know, though, is that when this stuff happens too quickly, and it happens drastically, the consequences are also drastic, okay? And we have recognized many periods in the history of life that we call mass extinctions, that have come about for many different reasons, but they have always involved drastic environmental change. And what we know now is undoubtedly we humans are causing drastic climate change, okay? Drastic, like something that we don't measure even with everything I've shown and told you, okay? The rates of change that we're causing are drastic. And you factor in the last 10,000 years of hunting and extermination and repopulation of species around the world, and the rate of biodiversity loss even before the modern industrial period. And we as scientists have already labeled the last 10,000 years as we've known 5 major mass extinctions in Earth history, and we're already calling this one the 6th, okay? So what's yet to come and everything we're told about the consequences of global warming, we've already done a lot, and it's only going to get worse if we don't do something soon. And sure, will life recover? Sure. Has it been through worse? Probably. But if you have 10 million years to wait around for ecosystem recovery, maybe that doesn't bother you. But I don't think we have that time, right?
Well, first of all, thank you very much for this very enlightening presentation. I was just wondering, in anthropology, do you have anything called conclusive finding, or it changes over time, and at some point you get surprised with a shock that the present finding contrasts your past finding, and it just like a topsy-turvy situation?
Science is always a process of exploration and discovery, and the first thing you're taught, you know, and should be taught in any science course is just to question everything. So if anyone tells you anything's conclusive, your first instinct is to say, really, how, why? Can I disprove it? Okay? And so if there's many hundreds of thousands of scientists of different cultures and different backgrounds working on different projects and coming together on certain conclusive things, then that's when we start to take them as facts. And other things are not conclusive, and they're hypotheses, and they're presented as such. And some things we think are more conclusive, and then they get overturned. They get overturned by new ideas, by new technologies, new ways of thinking. You know, I mean, we're human too, and each of us as scientists brings a cultural load and a social load and all this stuff, and we all perceive the world differently, which is also the process that why science, as a diverse, really democratic field of play, allows things to change, but also works towards a common goal of reconstructing at least what we hope to be a truthful history. Yeah.
Yeah, we mentioned before your talk about these fossils, the mammals they found in southern Oman.
Right.
What's the relationship between the Baynunah Formation and this location in Oman? Is this part of the same thing, same age, or?
Nope. So the Baynunah is around 7 million years old. These sites in Oman, there's multiple sites in Oman actually, but none of them are of this time period. They're actually older. And these recent discoveries in Oman, and there are some older discoveries by a French team there from the 80s, they're around 28 million. Okay, so they're much older than here, but they're very poorly known. I don't know if the sites aren't as rich as the sites are here, or if the work simply hasn't been done yet. I think there's a lot more to find all over the Arabian Peninsula, Oman included. But these discoveries are much older than the ones here, and they talk about a different life. I don't know if you remember on the reconstructions, the time period I showed you, the Baynunah, there's already an interconnectivity between Africa and Eurasia. There's a land connection. We take this for granted today, but Africa and Arabia were a single island floating off on their own for many, many millions of years. And 28 million years ago, Arabia and Africa were the animals you find there, you would never ever find them anywhere else in Asia because they're part of this continental island fauna, which is another interesting time, much farther away from the world we know today. Yeah.
So I think if there are no more questions, then could we all thank Faysal Bibi for a wonderful lecture.